Hello all, welcome to ASE Kalkitech webinar series. Myself Fahid. Today we will be dealing with third series of webinar on 61850. Today we are going to deal with 61850 tools used for engineering, simulation and doing the testing. So far we have been dealing with a lot of theory session. Today we will be moving with some tools and demo on the tools on the 61850 aspect like engineering, simulation and testing. So far in the 61850 previous sessions, we have covered an introduction containing all the details of 61850 on an introduction perspective, why the standard is needed and what are the different concepts. Then on the second session, we dealt on the overview of 61850, specifically stressing ACSI and its model, logical nodes and other concept here. Today's agenda is substation language overview. Again, we will be moving on to some of the concept of substation language overview. Then what are the tools that can be used for engineering, simulation and testing? And we will be going an overview of SCL manager and engineering tool, overview and features, followed by its demo. Then we will be continuing with ASE61850 IED Smart, which is a simulation tool. Whatever we have engineered, we can simulate it in lab environment and simulate all the IEDs in the lab environment for testing purpose. And that is the tool known as IED Smart and demo of that tool, and followed by 61850 client test tool, that is actual IEDs can be using client tool we can test actual IEDs, all its features and demo of that. So for demo of all the tools, we will be having 61850 expert, and especially on the tools, Mr. Sterin will be covering all the demo of the tools. Now moving on to 61850 substation configuration language. This is the basic of doing any configuration and any tool. All the tools which we are talking about will be using this SCL, and it is an XML based representation of 61850, its models, its communication elements, everything on XML based representation, and a schema is defined for the configuration of IEDs and substations, and this ensures that the complete system is interoperable with the exchange of configuration data between different substation engineering tools, interaction and other things. So this is basically SCL scope, file types and interactions. I have gone through this in the first session, but since this is relevant in the tool scenario also, I'm just going through this once again. So we are going into if you are going from top to bottom up approach, we call it as a top-down approach. The first thing what we need to do is system specification, that is a substation. What are the SLD of a substation, what are the elements of the substation, like a transformer, breaker, everything is defined in this system specification, and it is configured as a system specification description SSD file. And SSD file along with the IED capability description, that is a published file of all the IEDs, that is known as an ICD file, that will be used for each IED, importing each IED onto the system and mapping from the SSD element. The actual data will be coming from this ICD files on an IED, and this is done by the system configuration tool. And the output file generated is substation configuration description, nothing but an SCD file, and this will be handed over to corresponding IED configuration tools, which can be used to configure the specific vendor IEDs. That is, vendor IED configuration tool will be provided with a SCD file, and vendor IED tool will be used to configure the corresponding vendor IEDs, and this SCD file is converted into a configured IED's description, that is a CID file, and that will be downloaded, that can be downloaded onto multiple IEDs on the system. And there can be instead of using direct ICD, which is a superset of IED capability, there can be a project instantiated IED description file, which is can be a subset of ICD, and that is actually used in the substation, can be a configuration that can be used for the system configuration to create an SCD file. Since there are other standards like substation to substation communication is there, substation to control center communication is there, system exchange file is also an important parameter which is defined under SCD. So these are some of the files that is important, and exchange between the systems with the files so that it is completely interoperable. Then moving on to engineering, simulation and testing tool. So we have a complete ASE61850 suite that helps for engineering, simulation and testing tool. So ASE61850 is divided into SCL Manager, which is an engineering tool, IED Smart, which is a simulation tool. All the SCD elements can be simulated with the virtual IPs and tested it out, and it also has a test set, that is a client tool that can be used to test the actual IEDs, debug actual IEDs and other stuff. So this is also have an extension. All the substation, DER, wind and hydro power plant extensions are supported by ASE61850 suite. Complete package supports that. This supports all the file types including ICD, SST, SCD, IID and SCD files, depending upon where you want to put this tool out. So this is general overview of ASE61850 tool set comprising of 3 different tools. Now moving on to first tool, that is engineering, which helps for engineering the 61850. So that tool is known as SCL Manager, which is nothing but an engineering tool. So SCL Manager is a leading 61850 substation configuration tool in the market, and it helps for 61850 substation configuration, and it is completely OEM independent, so it is vendor agnostic. Any tools it can be used to this SCD created by SCL Manager can be imported in any of the vendor tools, and vendor IID or ICD can be imported onto SCL Manager. So that is a specialty. Then this allows creation, configuration and viewing, editing all the substation elements, 61850 specific data models, everything is supported in the tools. Then all the file types including SCD, SST, SCD, ICD, IID files with the SLD also can be done using the SCL Manager. And it has got a hydro, wind, DER and other substation elements, everything can be defined. Different IED files, IED configuration files can be inter-exchanged, and we performed multiple, involved in multiple interoperability events organized by UCA, and everywhere we were successfully established successful interoperability with all vendor tools. So this is completely vendor agnostic SCL Manager. It also supports version 1, 2, 2.1 and allows mapping of 61850 signal to one and to another IEDs and do the complete testing, configuration. Everything can be done using the SCL Manager. So complete engineering tool, all the engineering of 61850 can be done. Now moving on to SCL Manager demo. So in this session, Sterling will be dealing with details of SCL Manager. Giving mic to
ASE 61850 SCL Manager is a SCL import export tool. It also facilitates the IEC 61850 engineering of the substation. Today we will see how to use the tool at a basic level, importing the ICD or SCD files, and how to browse through different options in the tool. So let us start with the project. While creating a project, you can specify the name of the project. And further, it's possible to select the type of the 61850 station. It could be a substation, it could be a hydro power plant, or a distributed energy resources plant, wind power plant, or a system which accommodates all of them. Since this is a introductory video, I would go with substation, which is the most generic use case of 61850. It's also possible to support two types of SCL files in the project. If the project need to be accommodated with both edition 1 and edition 2 files, then you need to select edition 2 here. But if the project is only going to accommodate edition 1 files, then it is okay to select the edition 1. So based on the SCL edition selected, the SCL version is automatically set. Click OK to confirm. Further, on the left Explorer, there are different options available. It's possible to create the single line diagram. It's also possible to create the network diagram. And finally, it's possible to add multiple IEDs into the project. During this video, I would like to highlight how the IED configuration part is done. So for that reason, I will import the ICD file into the project. So there are three options available while adding the IED. It's possible to create a new IED configuration file. This feature would be useful for the original equipment manufacturers who has a new IED to be defined. Other option is to import from IED database. SCL Manager comes with a simple database which can accommodate multiple SCL files. So it's possible to import the vendor files into that IED database for a later use. The most commonly used feature would be to import from file system. So if you have the vendor files available with you, can directly browse the files and import into the tool. So in this video, I would like to focus on the import from file system option. So let us browse the file. So this is a file I have with bay controller capabilities. In the wizard, it will show the IED name. It's possible to change the IED name at this point or at a later point of time. It will also specify what is the version of the file. There are two options available to set at this point. IED configuration tools gives the user more options to change the configuration of the IED, and system configuration file restrict the user from setting some detailed features of the IED. For example, logical node addition feature will not be available under system configuration mode because the logical nodes are normally added by the vendor or the manufacturer of the IED. So if you want to play around with the tool, more, it's better to go with IED configuration. Otherwise, tool may restrict you from doing certain operations. Click Next. Further, it is possible to set the subnetwork of the 61850 substation. By default, there is an entry provided from the SCL file, but it's possible to overwrite that name with something else. So that if you need a different subnetwork name, it is possible to assign it here. Same is the case applicable to the access point. Addressing part can be changed at any point of time. So here we have an option to set the IP address, subnetwork, subnet mask, gateway, and other OSI parameters. Click Finish to import the file into the tool. Double click on the icon or the IED name to open up the configuration of the IED. So first tab gives the list of IED data model, and second tab specify the services available in that IED. We'll come to that later. Right now, you will see the IED data model tab. Under that, the access points are listed. There are options to add the access points or edit the access points or even change the subnetwork. Subnetwork of this IED as per the current configuration is listed here. Further, the IP address and other connectivity information of this IED is provided. Under MMS communication details, you could see or edit all these informations from here. Further, it's possible to view the Goose communication details. In this IED, we have 3 Goose control blocks. The properties of the Goose control blocks, including the destination MAC address, is provided here. The last section is to list down the sampled value communication details. As of now, in this IED doesn't have any sampled value control blocks, so that section is blank. In the next tab, it will list down all the Goose control blocks, and here it is possible to edit or change some of the Goose control block parameters. Double click, select the logical device here first. The selection is provided as all, so that means it will list down the Goose control blocks of all the logical devices under this IED. And there is an option to filter it based on the requirement. Double click on the entry to get a pop-up where user will be able to edit the properties: name, application ID, dataset, configuration revision, etc. can be edited. On the right hand side, the network addressing part of the Goose can be edited. It is possible to specify the application ID, VLAN priority, etc. on the right hand side here. And RGoose capability is also available in this tool. So if the IED is capable of sending out RGoose packets, it's possible to set it here. Click OK once you make the changes. And further, the report control block screen is provided. The same fashion, double clicking of a single entry will pop out the detailed options, and it's possible to make changes here as per the requirement. Datasets are also available for viewing or editing. Double clicking on an entry will give the current elements of the dataset on the right hand side. It is also possible to delete the entries by right clicking on a specific entry, or it's possible to add other elements from the logical device or the logical node using this option. Then there is a logical node data tab available. I skipped the sampled value as well as the setting group tabs because those will be present for the protection IEDs or the merging units. This is a back controller device, so it doesn't have a setting group or a sampled value control block. It's possible to select the logical device from the filter here, and the entries of that specific logical node can be viewed on the right hand side. So in this fashion, it is possible to browse through all the elements in the 61850 IED. Under IED configuration tool, it is possible to add the logical devices or the instances of the logical node. It's also possible to edit the name of the logical device, change the prefix basically, and also possible to edit the type of the logical node. So these options are only available under IED configuration 2 mode. Under system configuration mode, user is not supposed to make changes to the IED data model, so these options will be hidden. It's possible to set certain parameters into the configuration by setting the corresponding values here. So this summarizes the basic options available in the tool. I will come up with a different video to explain other options in the tool with respect to report configurations to a client IED and also for the goose mapping from one IED to another.
Okay, after SCL Manager demo, we are moving on to IED Smart. So IED Smart is a simulation tool. So after the SCD file created by the engineering tool, the same SCD file can be simulated in the lab to have multiple IEDs simulated in the lab with the virtual IP. So, that is done by the IED Smart tool. So IED Smart is a fully functional 61850 IED or relay simulation tool with 61850 server functionality, and it also has got a scripting feature and can be used for any simulating any components and any editions of 61850 standard can be simulated. Then it can be used to simulate multiple vendor devices, multiple electronic devices, IEDs, simultaneously with option of configuring virtual IPs. So in the lab environment itself, all the IEDs can be simulated for testing purpose. And some of the features supported are simulation of all the standard SCL file as per the 61850-6. It support logical nodes and common data classes of substation, hydro, wind and TER file. Simulation of multiple IEDs are supported altogether. It support all 8-1 services, MMS based report, logging, all the functionalities are supported, plus Goose also is supported. Data simulation with the millisecond accuracy is available. Tree based view of the simulated nodes is available. Using that you can debug the steps. So moving on to IED smart demo, and Sterin will be handling the demo part. Thank you.
ASE 61850 IED Smart is a 61850 server simulation tool. It also has the capability to do Goose publishing and subscription. So in this video, I would like to highlight the basic capabilities of the tool by opening a sample project provided along with the installation. So to open the sample project, browse to the toolbar. You can either go to the menu option or choose the second option under the toolbar. You need to browse back to the IED Smart folder under Documents, browse to the sample projects, further go to the example. Then you will see the example project with extension SPJT. So this is the file extension of IED Smart projects. It will give you a pop-up to attach the IED, which is the sample IED, with the respective network card of the PC. So for that, you will have to click the rectify button, the first button in the option. It will list down all the network cards of the PC or the laptop. You may choose any one of them based on your need. In this case, on this laptop I have loopback adapter, which is Microsoft, and also the real tech network card. So there are two network cards available on this PC, and the remaining are virtual machines. So you make sure that you don't select the virtual machine network cards, because that may not be the one you want to choose while performing a simulation. The tool will also list down all the IP addresses on the machine. Based on the need, you can attach the IED to any one of the IP address. Network card ID will be used for the simulation of Goose for both reception or sending of the Goose. IP address will be used by the 61850 server simulation. The external client devices will be able to see this IED at this IP address. So during this video, I will use the loopback adapter and the respective IP addresses. Click OK to select the IP address. Certain log messages will appear indicating that IED is loaded into the project. You can expand the tree and find the IED under the project. This is a configuration with one logical device which has the name Kalkitech 1. It also has multiple logical nodes with datasets. The project is also included with sample scripts and sample simulations. First, I will explain how the IED configuration is done. Right click on the IED under the project and browse to view edit configuration. If you click on that, you will see the SCL file path of this IED. In this case, the ICD file has got name kalkitech.icd. And also you can see the IED name, access point name below that. Further, there is a report scan rate option available. So tool will scan for the data changes in every specified interval. So in this case, it is 2 milliseconds. So that means tool will keep on checking for data changes in every 2 milliseconds, and that will be available to the external client via reports. Here you can see the IP address selected for this IED and also the network card. An IED identifier is a name under the project for easy identification of the IED. So in this case, IED name matches with the IED identifier. And there is an option to create multiple instances of this IED. In this video, we will stick to the basic simulation. So I will explain these options in another video. Click on next to see some of the advanced options of the IED. In this sample scenario, we have not selected the Goose publishing and subscription capabilities. So the sample project by default will run with client reporting capabilities, communication services, and other logging options. It will not by default enable the Goose publisher and subscription. But at any point of time, we will be able to select this box and enable these options. So I will take you to the display options of 61850 variables. You can select the logical nodes to see all the data points under it. There are two primary views provided to display the variables. The first one will be populated based on the selection on the left-hand side explorer. Based on the change in the selection, the data points listed on the right-hand side will be changed. So for any reason, if you would like to see different set of variables, you can simply click on the logical nodes or the required scope. Below is the watch variables. If you are interested in seeing a few data points all the time, you can assign those variables to watch window so that the view will persist as long as the window is open. There is another option called global watch window. It will pop out and will be a separate viewing option. Further, you could see the datasets. Values under the datasets can be browsed. And there are multiple scripts in this example. Scripts can be edited in this tool using certain functions. Details of the scripting has been provided in the user manual. So if you are interested in making advanced simulation using scripting, you may browse through those functions and familiarize with that. There is a simple simulation option which is configured using comma separated values. So in this sample simulation, you can see three 61850 variables are simulated with multiple values. So these values will be applied at an interval specified on the bottom left corner. It can be either made cyclic, or we can specify the number of iterations under which the simulation to be executed. So let us run this IED and see the simulation. So there are different options to trigger the simulation. The simulation can be auto started along with the start of the IED, or it can be started on a based on the demand from the user. That means it can be started using a mouse click. I'll keep it under auto start for the simulation. Similarly, scripts also can be auto started. By default, those are kept under auto start. I will change it to start on demand so that we can see them one by one. I'll browse to the top and select the IED and start the simulation. You could see below that the IED has been started and it has been associated with the IP address 10.0.0.1, which was the configuration available or selected. It also started the reporting service. And since the simulation was auto started along with the start of IED, you could see that these values are changing. These were the three values available under simulation. So the values are getting applied based on the inputs provided. So these values are applied at a periodicity of 5 seconds. So it will be continuously simulated, and if the clients connected to this IED, those clients can receive reports with these data changes. There are some scripts available in this example. So let us see some of the scripts and try to understand the same. In this simple example, it will monitor the voltage of the circuit, and it will also trigger the protection signal. So over voltage condition will be detected and under voltage condition also will be detected by the script. And based on that, the PTOV and PTUV, this operate and start, will be triggered. The condition is specified as greater than 234 voltage for over voltage condition and less than 228 for under voltage condition. Script functions can be familiarized by looking at the manual provided here under help topics. I'm not getting into the details of the script. So there are certain functions which will help you to get the handle of the 61850 variable. Once the handle is obtained, certain functions like write variable or read variable can be invoked. This is a normal VB scripting engine provided with the tool. So by using this programming method, any logic can be built and respective simulation can be achieved. So let us run the simulation and see the behavior. To execute a script manually, right click on that script and click on start. So based on the simulation, you could see that under voltage condition was detected. So it has triggered this under voltage operation. As the voltage go high to 234, the programming was done in such a way that it will detect a over voltage condition. So let us see how that is triggered. So the simulation is set at 234. We could also have other simulations executed along with the same script. So the detected conditions are listed under the log file. So as soon as the voltage or current varies, we can trigger the script to detect a condition and generate respective value changes.
Okay, so after IED Smart demo, we are moving on to the features of test set. So this is 61850 client test set, means you can test any of the 61850 server including the IEDs with the client tester, debug, troubleshoot, and it will also help you for the compliance needs. So that is the purpose of test set. So ASE 61850 test is a Windows based tool that enables operation and maintenance of any 61850 station and IEDs and it can facilitate testing, monitoring, control, troubleshooting, and compliance need can be facilitated by ASE 61850 test set. It can scan the network and identify, connect, discover all the IED model including logical nodes, data elements, report control block, data set, and you can even issue control commands. So it has got all the features that is necessary, including the complete SCL support, all the control block like report, goose, dynamic data set, and all the standards like 1.0, 2.0, and 2.1 are supported in the test set. Now moving on to ASE61850 test set demo, Sterling will be taking over.
ASE 61850 client is a 61850 client tool with Goose subscription capability. Today we will see the basic operations of the tool to connect to a IED and get the reports. After starting the tool for the first time, user will see a pop-up to select the network adapter. You will get a list of network adapters available in the PC or laptop, and we can select any one of them. In this case, I have selected the Ethernet adapter attached to the PC. Next operation could be the addition of IEDs into the configuration. There are two options available. One is to scan the 61850 IEDs in the network, or other option is to manually add the IP address of the IED so that tool can locate that IED in the network and connect to the same. First, I will show you the second option, to manually add the IP address of the IED. Enter the IP address. Once the IP address is entered, the tool will ensure the connectivity to that IED by using a ping. If it is successful, user can see it added to the list. By clicking OK, the respective IED will be added to the left pane of the tool. Similarly, we can add any number of IEDs into this pane and select one or more IEDs from that list to test the communication. In this case, I will select the only added IED. The connectivity parameters of the IED will be listed down. These are some of the 61850 and MMS parameters, which includes some OSI addressing as well. Further, the second tab in the same pane can be selected. Once the tab is selected, the 61850 client will try to discover that IED configuration from the network. It will connect to the IED, and using 61850 operations, it will fetch the configuration and data models of the IED. It could take longer based on the number of points in the IED or based on the logical devices it has. So in this case, I am loading a sample configuration. And we don't have so many logical nodes here. Further, the parameters required to be monitored can be added to the right hand side point list. As an example, I will add a few measurement data points. Once the points are added to the point list, tool will automatically poll the values from the remote IED. Updates of the values will be highlighted using yellow color. The same fashion, any number of points can be added into the IED. Now we can add a few digital points like circuit breaker position, trip conditioning signal, okay. So now we have a handful of points listed here, and tool is continuously polling the data values from the remote IEDs and showing the updates. Another option is to get the values from the IED through other means, which includes reporting. To enable reporting, you need to go to the tools menu and click on the view reports option. All the report control blocks, which include both unbuffered and buffered report control blocks, will be listed here. To verify that data is fetched through reports, we might have to disable the polling in the tool, and for that there is a column which will allow to select between polling and non-polling of a data point. To test the reporting, it is important to uncheck this option. We can have both polling and reporting enabled at the same time, and based on the last column indication, user will know how the data point arrived in the tool. So there could be a toggling between read and report if the same data is fetched through both means. So let us go and enable a few reports. First, I will enable a trip conditioning signal report, and the details of the report control block is visible here. Option fields, trigger options, etc. can be set appropriately, and the data set associated with that report also can be viewed along with the data elements in that dataset. I will select breaker status as well as a measurement report to fetch the measurement data from the IED. Once the required reports are selected, you can click OK. Now the tool will try to enable the selected reports automatically based on the option fields and trigger options selected by the user. And data updates can be viewed by looking at the highlighted rows. Recent updates will be highlighted using yellow color, and source of the information, timestamp of the data, value, etc. will be updated appropriately. So along with the reporting, read of the other variables also can be enabled. So if any data points are not available in reports, those can be fetched using read option. History of data changes or data updates are visible by using the history option here. That can be viewed by clicking on a specific data point. Based on the selection of the row, the respective value changes, timestamp, and source of the data, etc. will be visible below. Further, there are event logs, which gives the summary of user operations and also the history of read operations performed by the tool. Then reports with details of data, and finally ghost messages, which we will cover in a separate video. So these are the different options available in the tool. Control operations can be performed by going into the third pane on the left hand side. By selecting the third tab, there is a detailed view of data points available. In the second tab, it basically gives the list of status and measurement values. Those can be added to the point list. Under the verbose tab, there are more options available, which includes the listing of ghost control block, buffered and unbuffered report control blocks, datasets of the report. Data points associated with the dataset also can be viewed in the bottom pane. And by browsing into the control, we could perform control operations on IED. By selecting the respective control wizard, we could initiate different type of operations supported by the IED. Could see the current value as false. You can select that data point so that it will be updated appropriately. So I have added that point into the point list. And we could issue a control operation into it. So the current value is false. So let us trigger the value change to true and find out what happens. Okay. In this case, could see that the control operation was successful and IED returned the value true immediately. Based on the control model of the object, different type of operations will be allowed. So this is a direct operate control model. That's why the respective options are enabled. As you can see, the value which was forced is reflected in the status value. So this is the summary of basic operations which can be performed using ASE61850 client tool.
Okay. Thank you, Sterin, for all the session, demo sessions. With this, we are coming to end of third session of 61850 webinar. We will be continuing with the fourth session as well. You can contact us in any of the mail IDs given below. Thank you all for attending this session.